All right, in this section 9.1, solving differential equations, this will be a really brief introduction to what many of you will ultimately take in a differential equations course. So you've already solved differential equations. You might have encountered them in Calc 1, maybe perhaps under the name of an initial value problem. But the idea is, you're used to solving equations from algebra. An algebraic equation is an equation where there's going to be finitely many solutions. Essentially, it is a point. Or if we have higher order equations, maybe those solutions could be something else. But essentially, it's a point. We're getting a finite number of different solutions. For instance, if you solve a quadratic, in general, there are 2 solutions. A cubic has 3 solutions, so on and so forth. Here, things are going to be changed. We're going to change perspectives a little bit here. So a differential equation is an equation that contains an unknown quantity. So in this case, the unknown would be y. Or not just unknown, just a quantity, let's say y. And this quantity y depends on x. So y depends on the value of x. So implicitly, there's this functional relationship. And the differential equation contains, potentially, the unknown quantity itself, y, and the variable on which it depends. So really, it's a way of describing how something changes, because a derivative is a rate of change. So given how something changes, if we know how something changes, can we figure out what that thing is? All right, so let's take a look at example 1. Example 1, verify that both e to the x minus 4 and negative 4 are solutions to this differential equation. So instead of solving like an algebraic equation where we will get a point as an answer, as a solution, the solutions that we're going to find are not just a single point, but an entire equation or a relationship or a function. It's not just one point, it's infinitely many points. So let's go ahead and take a look at this. So to verify that a solution is a solution to, or excuse me, let's rephrase that. To verify that some sort of relationship, here y equals e to the x minus 4, for instance. So we're going to use y is given by this particular function. To verify that that is a solution to this differential equation, we really just want to substitute that in for y into the differential equation. So I always do this by looking and working with one side at a time. So for our f of x example, we're going to let y equal f of x, which in this case is e to the x minus 4. So then the left-hand side of the differential equation is y prime minus y. Well, if y is equal to e to the x minus 4, then y prime is the derivative of e to the x minus 4 minus y, so e to the x minus 4. So if we differentiate, we get e to the x minus derivative of a constant is 0, minus, we'll distribute, so minus e to the x minus minus, so plus 4. The e to the x's cancel out, and we're left over with the number 4. And you can see that number 4 is just exactly what the right-hand side is. So we started with one side of the equation, and we worked in an orderly fashion until we arrived at the other side of the equation. The fact that the left-hand side matches the right-hand side upon substitution, that verifies this e to the x minus 4 as a solution to the differential equation. We can do it again, this time with our g of x, which is just the number negative 4. So, I guess I'll make this the same format. So this time we'll let y equal negative 4. Then the left-hand side, again, is y prime minus y. So the derivative of negative 4 minus negative 4. Well, the derivative of any constant is 0, and then double negative, you get plus 4. 4 is exactly the right-hand side. So again, we get agreement between the left and right-hand sides of this differential equation. So this also verifies that y equals 4 is a solution to this differential equation. So both f of x and g of x are solutions. Same idea. Example 2. Verify that y equals 1/3 x squared plus c over x is a solution to this differential equation. Okay, so we'll start with the left-hand side and work our way in an orderly fashion until we arrive at the right-hand side. So the left-hand side is y prime plus y divided by x. Okay, so y prime is the derivative of 1/3 x squared plus c over x. Then we have plus, I'll do the 1 over x off to the side, and then I'll just write y right here. So this is us substituting into the differential equation the proposed solution, y equals. Then we follow the instructions. We take the derivative, so this would be 2/3 x minus c over x squared plus, and then we'll distribute. So this will be 1/3 x plus c over x squared. Now, of course, the c over x squareds cancel. And then we're left with 1/3 plus 2/3 is 1, so 1x, which is the right-hand side. So that implies that this is a solution to the differential equation. Now, some of you might be wondering what the value of this c is, or what's the role of this term c. Well, this c just stands for any real number. It's just a placeholder. Sort of like when you integrate and you get plus c at the end of your answer, it just is representative of any constant. Different values of that constant will give you different, well, in the case of integrals, it gives you different antiderivatives of the same function. And in the case of this solution, it just gives us a different solution to the differential equation. All right, so this right here implies that y equals 1/3 x squared plus c over x is a solution.